Hello everyone. Here we're going to introduce the binomial theorem. In the previous videos we've been doing, we discussed about the expansion of say x minus a in the last video, x minus b, and then x minus c. We say this is equals to x to the third power minus a plus b plus c x square plus ab plus bc plus ac x plus not plus but minus abc. So this was the topic we discussed. We showed how to do this. Next, we also showed how to do the case for when we have four factors. In this video here, we're going to consider x whereby we have n factors. Let's say we have x minus, say in this case we have a1, x minus a2, x minus a3. Then we have it continuously, x minus an. So we have n factors in total. Well, this will be equals to, first of all, we have x to the n. Let's say plus p1 x to the n minus 1 plus p2 x to the n minus 2 plus p3 x to the n minus 3 plus p plus pn x to the 0 power. Yeah, I think that is, yeah, that does it. Pn x to the 0 power. Now what we are going to ask is that we know that this expansion obviously is in this form, because for all the expansions we'll do, we will have to put it in descending power of x. Just like here we have x cubed, x squared, x, and then 0. Just that this time around there was no p1, there was no p, like there the p1 is represented by a plus b plus c. This is the p2 and this is the p3 here. For this case now, we're going to look for what will be the case of p1. Well, to answer that question, we are going to ask ourselves, how do we form the product x to the n minus 1? Well, to form x to the n minus 1, we go through these brackets, this n brackets, we loop through it. N minus 1 of them will be taken out. So we pick one x here, one x here, one x here. We multiply until we get x to the n minus 1. So it will remain only one bracket here. So that is how we form the product of x to the n minus 1. So that number we see multiplied by x to the n minus 1. So maybe it may be a sub n. And then likewise we may see start from here and go through it remaining a sub 1. So it can still be a sub 1 x to the n minus 1. I've already explained this process in detail in the previous chapter. The next step is that we may still have a sub 2, still x to the n minus 1 as well. So what we'll be having here is that the first of the p1 will be the sum of a sub 1 plus a sub 2 plus a sub 3 up to the an. Yeah, that is what p1 would be. Here again, because to form the p1 here, we will have to select n minus 1 x's here, remaining one bracket, and we'll multiply them together. And sorry, I should be putting this, should have a plus sign here. The case whereby it has a minus sign will be considered later. For now, first let's just work with the plus sign. So this is what the p1 will look like. So what will p2 look like? P2 would be here. We'll pick x to the n minus 2. So we'll pick all the whole x's in the bracket except for 2 brackets. So for each time we pick the x's, we'll be multiplying by 2 of the numbers here. So we'll be having the coefficient should be a1 a2 plus a2 a3 plus a1 a4, like, plus maybe an a1 as well. It has to be this a1 a2 a3 up to an, but then we're going to be picking 2 at a time. So p2 is the product of all the terms taking 2 at a time. So this one we will take it one at a time, one at a time, at a time. This one is 2 at a time. What about the P3? P3 is gotten from taking x to the n minus 3. So we have n minus 3 brackets. Remaining 3, it will remain 3 brackets. So the remaining 3 brackets, we multiply them together. The terms in the brackets like a, b, a1, a2, a3 to form it. So we'll be having a1, a2, a3. This is similar to what I've explained before, and then there's no point in really rolling over it. Please, if you find it confusing, please I suggest you go through the previous video we did on integral function, because I've covered this a whole lot. So maybe a2 and maybe we may have a4, but it's just like we're taking the product of this thing, but we're taking 3 at a time this time around here. So what we'll be having is that we'll be having that x plus a multiply x plus b, then continuously will be, say, x to the n power plus p1 x to the n minus 1 plus p2 x to the n minus 2. What the p1 is the a plus b plus c continuously, and then the p2 will be ab plus bc plus, say, ac, and so. Let's look at a numerical example. Next, suppose you have to distribute this x minus a, x minus 2a, and x minus 3a, x minus 4a. Obviously, it has to be in this form, x to the 4. Then this will be a minus here. This will be a minus. The reason is because we have adding the terms. Here, the general case of this, which I did not state here, is that since we said x plus a, x plus so x plus a1, x plus a2, x plus a3, all continue multiplying x plus a sub n, it will be x to the n power. Then here we have to minus p1 x to the n minus 1 plus p2 x to the n minus 2 plus, it will be plus negative 1 to the n p sub n x to the n. This is the general way of writing this, because for this case here we are going to add all the terms, so it will be negative, and the second case here we are going to multiply them taking 2 at a time. So in this case is when we have the minus sign affixed. So we have a minus sign. What am I even doing? So like when we have a minus sign, when you have the plus sign, just a plus throughout, but the minus sign we have to fix this minus negative 1 to the n throughout there. So for this problem here, which we are going to return to, this will be minus, let's say we have p1 x to the third power plus p2 x to the second power minus p3 x to the first power plus p sub 4. Like I said, p sub 1 is gotten from the addition of all the terms here. Why? Because to form the x to the third power, what we need is to pick 3 x's here, and then the remaining one can be combined with that x we have picked. So we are going to have negative 4x to the third power. Still, we are going to still pick 1x, 2x, 3x here. So the remaining one we have to combine with x to the third power. So we have to have negative 3a x to the third power. So all we will be having will be, say, p1 would be equal to x to the, we equals to negative a first of all. No, but we don't have to put negative a. We just only the terms here, like a plus 2a plus 3a, because negative has already been taken care of here, plus 4a. That was what p1 would equal. Everything will be, so this is 6, 10a. What about p2? P2 will have to be the product of the term, but we're taking 2 at a time. So we will multiply a and 2a, and we multiply a and 3a. Then we multiply a and 4a. Still here, we multiply a, 2a, and 4a. And then we multiply 4a and 3a. And what else have we not done? Have we multiplied 3a and 2a? Then we multiply 3a and 2a. So that's like taking 2 at a time. So everything should give us 1, 2, 3, 4, 5, 6 terms here. So let's see. Are we missing a factor? No, it's 3a multiplying 2a. So we have combined a and 2a, 2a and 3a, 2a and 4a and a. So I think we are done. So this will be 2a squared. All of them has a squared even, so no point. Just this is 2 plus 3, 5 plus 4. You will have a 9 plus 8, 17 plus 12. So this is 9, 29 plus 6. That is 35. So this is 35a squared for P2. What about P3? P3 is taking 3 at a time. So P3 is, we're taking 3 terms at a time. Here, I think I've explained this well enough. Let me not sound repetitive. To get this P3 here, we take 1x and then 3 terms here, 2a, 3a, and 4a, and multiply them together. That's how we take 3 at a time. So yeah, the P3 part here would be a multiplying 2a multiplying 3a, then plus probably a multiply 3a and multiply 4a. Then we'll be having a 2a, 3a, 4a, and then 4a, 2a, 4a. So a will multiply 2a and then 4a. So what is it 4? Yeah, I think it's 4. I think we are done with them because 4, 2 and 1 has combined. I think we are done. So no point in actually multiplying the a's. It's a cubed, but here we have 6 plus 12, that is 18. Here we have 6 times 4, 24. So have 18. We have 18 plus 24 for this part here. 3, 5, 52. So here we have to add 8. So that is 60. Hopefully I'm not mistaken. So this is 68 to the third power. So the piece of 4 is a times 2a times 3a times 4a. So that is 6 times 4, 24. That is 24a to the fourth power. So everything is x minus a, x minus 2a, x minus 3a, x minus 4a is then x to the fourth power minus p1 x to the third power plus p2 x to the second power minus p3 x to the x plus p sub 4 in this case here now. So p1 give us 10a and p2 is 35a square. So this is x to the fourth power minus 10a x to the third power plus 35a squared x to the second power minus 60a cube x to the third power plus 24a to the fourth power. So I hope we are sure. So let's count again. The one I doubt the most is this 60. Let's see. For this 60 part, does this thing equal 60? This is 6 plus 12, 18. And then 18 plus 6 plus 24. That is look, this is 42. And I got 52 here. I think everything should be 50. Oh, sorry about that. So everything here should be 50. So we should have a 50 here. So this is the correct expansion for it. Obviously this video has been long enough, so let's stop here now, and then when we come back we will introduce our normal binomial theorem. We have introduced it though, this is the binomial theorem. But we're going to discuss it further in the next video, it's next part of the video. Yeah, so please subscribe to the channel if you like my content. Have a nice day and see you next time.